Hello, friends. Welcome to the Nexus Podcast. I'm your host, James Dice. Each week, I fire questions at the leaders of the smart buildings industry to try to figure out where we're headed and how we can get there faster without all the marketing fluff. I'm pushing my learning to the limit, and I'm so glad to have you here following along. This episode is a conversation with Liam Bates, CEO of Kaiterra, and Shona O.D., Principal and High Performance Design Leader at DLR Group. We talked about all things indoor air quality in 2022, including wading through all the noise on this complex topic and what an integrated IAQ strategy is all about. I learned a ton in this one, and I even measured the IAQ in my office as we spoke. So without further ado, please enjoy the Nexus Podcast with Kaiterra and DLR Group. All right. Hello, Shona and Liam. Let's start with you, Shona. Can you introduce yourself, please?
Sure thing. So my name is Shona O.D. I lead the high performance design team at DLR Group. DLR Group is an integrated design firm with 29 offices, about 1,300 employees, and my team really focuses on supporting our designers in the pursuit of high-performing buildings. And so we do that in the design phase through simulation for design assistance. We do a lot of master planning work and also IoT deployments at scale.
Cool. And then you'll be the second DLR Group guest. We had Rory back in mid 2020. Nexus and DLR Group are big fans of each other. So glad to continue the string here. And where are you located, Shona?
So I'm in the Sacramento office.
Okay. And while I was preparing for this, I realized that you're a Boilermaker.
Yeah. So ended up in a pilot exchange program from Ireland to Purdue. So I got to spend a year in West Lafayette and actually ended up living in the Midwest for 8 years after that. So.
Okay. Cool. My grandpa was a Boilermaker, which is why I wanted
awesome.
to bring that
Okay.
up. Yeah. He went to Purdue in the 50s. Yeah, so long time ago. So did you come here for college and then stick around in the US after that?
Yeah, so it was kind of a funny story. I graduated from Dublin Institute of Technology, which Rory did as well. So both came from the same program. And I was set up to start a job in London in Cundall Engineering. And I kind of won the lottery, I guess. 7 students were chosen from Ireland, 7 from Spain, and then 7 from Purdue to do a dual master's program in sustainability. And it was all funded. And so kind of went on an adventure around these different universities, obtained a dual master's in sustainability. And then when I finished my studies, really wanted to stay in the Midwest. And so at that time, there wasn't really a defined position for someone with my background. And so I researched a number of sustainability leaders in the Chicago market and flew to Chicago and asked them to meet me for coffee. And Rory Barnwell was one of those people and has been at DLR Group ever since. So
cool. And Rory wasn't the one that connected us. So we got connected through Kaiterra, I think, which is great. So Liam, I'd love to introduce you now, or for you to introduce yourself.
Known Shona for several years now and spent lots of time talking and nerding out about indoor air quality together. So excited to be here and chat about this today. So my background, I'm originally from Switzerland, complicated family history with parents from various corners of the planet. And I was born and grew up in Switzerland on a halfway up a mountain in the middle of nowhere. Our neighbors were mostly cows, not too many people. And I spent a lot of time around technology when I was younger, got really into programming, taught myself to program sort of in around middle school, and eventually through a lot of sort of twists and turns, ended up starting Kaiterra. And our focus is really on indoor air quality and really creating hardware, software, and analytics to be able to help us understand what's going on within our environment and understand the air quality inside buildings so that ultimately we can make buildings healthier places for the people inside them, but also more sustainable. So that's what we're all about.
So why don't you have an accent?
So I grew up speaking like English and French, bilingual.
Okay.
So my Yeah, my was originally from the US. My dad's originally British, grew up in Africa. I was born and grew up in Switzerland. So I spoke French, English at home, French everywhere else. And then I went to university in Canada. So some people say I have a
Okay.
Canadian accent now.
You sort of do. Yeah. All right.
I don't know. I used to have a very British accent when I was like under about age 10. And then
Okay.
it morphed over the years into whatever this is.
All right. All right. Okay. And then when I was stalking you, I noticed some Travel Channel stuff. Can you talk about that?
Yeah, I mean, so my personal history is totally all over the place.
Yeah, it sounds
um,
like.
I've always just sort of done what I find interesting and followed whatever passion I have at the time. And as long as it's something which I think is fun and meaningful and helpful to the planet, then I'm totally happy to go and dedicate my life to doing that. And so for several years, I was making documentaries about travel and mostly so I was making shows for example, Discovery Channel, the Travel Channel, and these were documentaries often about say dwindling populations around the world that were living in lifestyles that might be quickly vanishing. It was super interesting. So I spent several months floating on a boat in the middle of the ocean, for example, living with a
Cool.
family on a deserted island, and yeah, just amazing experiences. And it's fascinating to capture those stories and then tell them to the rest of the world. I thought that was really valuable.
All right. Cool. I have it on my list to like go dig up some of these, but I haven't done it yet. Full disclosure. Well, maybe we'll have to try to find them and put them in the show notes. Well, cool. And you said Kaiterra. What year did you start Kaiterra? And what was the impetus? Why did you decide to dedicate your life to indoor air quality?
Yeah, so we started in 2014, and
Okay.
it was really just a passion project that got a little bit out of control, very out of control at this point. So really, it was actually my then fiance, now wife, who so she had asthma when she was a kid, and then it grew out of it, as often happens. And then in 2014, I was in living in Beijing at the time, which is famous for not having the best air, and she was planning to move to Beijing for a few years, and basically just it was like, is the air in the house that we are renting safe? Is it is it okay or absolutely terrible? And the reality was there was absolutely no way to find out. There was nothing on the market that could help you understand, is your air safe or not. And so yeah, weekend project became quit my job, became here we are 6 or 7 years later, and along the way found that actually this is a really massive problem, not just in places like Beijing or New Delhi, but really everywhere for just about everybody on the planet. We all spend 90% of our time indoors. We're all breathing air, and we also waste a lot of energy doing often pretty dumb things with our air, heating it, cooling it, moving it around when we don't need to. And so there's going back to sort of following my passion and trying to um, sort of dedicate my time to a useful cause. I think this really ticked those boxes, and so that's why I'm still here.
Absolutely. And here we are. And I have over my right shoulder here, Kaiterra monitor that's in my office, realizing that I'm inhaling a lot of my own exhales, a lot more than I thought. So I guess, yeah, thanks for doing that and going on that journey. And here we are. So let's talk about, I think before we hit record, Shona, one of you mentioned Wild Wild West of indoor air quality. And I think that's a great place to kind of kick this conversation off. Shona, you've been thinking about this problem for a lot longer than I have. It sounds like maybe longer than Liam has as well. So can you talk about kind of the history of indoor air quality and maybe like how you guys at DLR Group have approached the problem historically?
Yeah, sure thing. And just to reflect, if we call it the Wild Wild West now, I don't know what it was like when
Yeah.
when I started trying to shop for indoor air quality monitors. But I guess just thinking back to when I started at DLR Group, I was coming into the firm as a simulation professional, and we had a lot of master planning work. So one of my first projects, I was asked to create a performance grade for a large portfolio of buildings, and K through 12 buildings. And so the process that we created for benchmarking those buildings was quite heavily rooted in the philosophy that energy is only one piece of the performance pie. At the time, we actually had a presentation called 99 Problems and a BTU ain't one to really educate people on holistic building performance. And so when we went into the different buildings on a campus, we were benchmarking energy performance, yes, and water performance, and then also quantifying a metric for visual comfort, thermal comfort, indoor air quality, and acoustical comfort. Wow. And so the idea was to have a really wide field of view of a building performance, so that a low energy building that may not have mechanical ventilation was not getting a better score. Okay. And so, a real challenge around that is, how do you quantify? It's difficult to benchmark things like indoor air quality and thermal comfort compared to something like a simple energy per square foot. And so we created a three-pronged approach in doing so. And so we identified different performance indicators that we could observe with our eyes and would walk through the space to identify them. We had a scorecard for that. We also issued thermal comfort surveys and then started to use sensor technology as well. Okay. The way that started was really just borrowing some sensors from our commissioning group. And so, they had some hobo data loggers that were measuring temperature, relative humidity. They had some CO2 sensors, some decibel meters, and we purchased some foot candle meters as well. Okay. So that was really the impetus of the process. And so since then have really been evolving that process and have stepped away from some of those point in time measurements where you're kind of making a building smart for a little while, instead deploying more permanent indoor air quality monitors in spaces. And so a big game changer for us was some funding we had internally at DLR Group in 2017, where I led an initiative to deploy permanent indoor air quality monitors in all of our offices. And so at the time, the reset air standard was only really being used in China, but one of the co-founders of that standard was in Chicago. And so we were able to partner with him, Ryan Dick, on figuring out a way to actually do IoT deployments at scale, and then went through the process of trying to purchase a large amount of air quality monitors and deploy them across our offices. And so I've kind of been doing so ever since. And that's really where I met Liam and Kaiterra. We were really dreaming up a certain type of sensor, and thankfully Kaiterra has built one that meets a lot of our needs that some of the other monitors didn't.
So yeah, that'd be a great segue, Liam, to just talk about what you guys have built, and maybe we can talk about why that's different than the rest of them out there.
Yeah, so I think going to the question that you asked at the start as well about sort of the wild westness of
we'll get back to that.
One of the challenges with air quality monitors is that they're basically white or black or whatever color you make them, boxes that output numbers that sometimes you can't see immediately. They, you might need a dashboard or integrate it into a building management system in order to view the data. Mm-hmm. And it is also incredibly hard to know whether or not they are giving you the right numbers, because, I could tell you, hey, your CO2 level is 600 ppm, and you might go, sure, that sounds plausible. Or I could say it's 2000. You might go, well, okay, I'm surprised, but sure. And so it's not like temperature. If I tell you it's 32 degrees right now, you're probably gonna go, that I think you're wrong. I can tell that is not a correct statement. But air quality is really hard, and that's across all parameters. And so this is I think one of the things that has made it really hard over the years to have products that are continuously providing readings, is that it's hard to know how accurate devices are. It's hard to know if the data that you're getting is accurate, and if over time there's a problem with the devices, they start to output incorrect data, you don't know necessarily if it's a problem with the device or if the air is actually changing, because you can't see it. it's something invisible. And so that's a really big challenge, and it's a big part of also how we design our products. So from a hardware perspective, we really try to build around standards that exist. So for example, there's the reset standard that Shona just mentioned. And within that, they identified a lot of the potential pain points or problems with monitoring air quality. And same thing with the well building standard as well, for example. They have certain features that are around continuous monitoring, and they have specific requirements around the the required accuracy, the required ranges, and perhaps most importantly, the ability to recalibrate devices. So really, when we design our hardware, it's built around these standards. And so a big feature of this is that we've designed all our products to have modules that you can replace. And this is addressing a couple problems. One is that device sensors need to be recalibrated over time. It's just a fact of science is that a sensor over a long period of time can drift and it can become less accurate. And if you're using that sensor to automate your building, for example, you want to make sure that the numbers are correct. Otherwise, you might be doing some really bad things with your building. And
Totally.
yeah, we don't you don't want that to happen. So we've just we've made sensors which are replaceable so that over time you can swap them out, you can recalibrate, and potentially you can also measure new things, because the industry is changing so quickly. What was important last year is not necessarily important this year. There's new technology coming out. In the world of COVID, people are suddenly interested in measuring other parameters. And you don't want to have to, next year when there's some new technology out to measure, VOCs more accurately, for example, you don't want to have to pull these hundreds of devices off of your wall and recommission with a whole bunch of new devices. That's just completely unsustainable. So we've tried to build this where you can think of it almost like printer cartridges, where you could change a black and white printer into a color printer just by swapping out a cartridge.
Yeah. And so the one that I have on my wall, you can swap out VOCs and particulate matter, I believe. And then the temperature, humidity, and CO2 are sort of embedded more deeply. Is that how it works?
Yeah, exactly. It's really, it depends on the technology that's used. If sensors, if they have a 12 plus year lifespan, then they can be built into the device. But something like particulate matter, I mean, what you're measuring is dust. By definition, you're going to get dust on the sensor. And a dusty sensor is not going to give you accurate readings. So no matter how well designed that sensor is, you're facing a fundamental problem that you're measuring something which causes the sensor to degrade. So it's important to be able to take it out, either clean it, replace it, etc.
So Shona, is that kind of that flexibility and maintainability, I guess, is that what you're talking about in terms of meeting the sensor meeting your needs?
I guess as we've gone through different types of deployments, we've learned a lot about what not to do. And so multiple features that the SenseEdge and SenseEdge Mini have kind of solved those pain points. To me, the first issue, or the issue that has caused me a lot of time loss, is around losing data. And so, typically with an IoT device, it's connecting to a network, and the network is then feeding the data to a cloud-based platform. And so, a lot of the time with other air quality monitors, someone might unplug them if they're not hardwired, or maybe the network goes down, or maybe the monitor stops connecting to the network itself for some reason. And if we lose data, that could mean we have to go through an entirely new monitoring period. So as a consultant, that's a lot of, that's our profit out the window when it comes to serving our clients. And then for reset certification, there are data loss limits. So if we lose the data, we actually lose the certification as well. And so that's something I really value, is that the monitors themselves have memory in them and can then re-upload the data if the monitor goes offline for a certain reason. That's part of it. Also, calibration is key. So the monitors that we've deployed across DLR Group portfolios, they don't have a robust recalibration option. And so at the time of deployment, that manufacturer told us that they could help us recalibrate. But then when we went back to them to ask for that help, we were told, yes, we needed to take them all off the wall. We needed to ship them all back to China and then pay import duty again to get them back into the country. And so, that's just not really, that's not a realistic option. And so there are certain monitors that are somewhat in between a great option like the cartridge option and no option. And that's really, where you're applying a drift factor in the dashboard to account for the sensor going out of calibration. While that might be sustainable for some applications, to me, it's not really something that we can deploy at scale.
Makes total sense. All right, so I want to kind of you told the history, and then at some point you didn't mention this little tiny worldwide event that happened, right? That made indoor air quality more important to everyone. And so I'm assuming at some point after you met Liam, the pandemic hit and everyone started to care about indoor air quality. Is that just my perception that there was a big boom after that happened, like for both of you guys, I guess?
I mean, I think the first boom for indoor air quality was when the Harvard School of Public Health cognitive function studies were released, where there truly was that link shown between cognitive function and indoor air quality. And then obviously, with the pandemic, the focus became much more of a widespread conversation.
Yeah, how about for you guys, Liam?
So the first thing is it depends a lot on the different regions of the world. So we're a very global company. We sell in really every corner of the planet. Our products are installed in something like 130 different countries, and the motivation can vary, but usually there's some sort of trigger. So the pandemic has definitely been a global trigger, and before that, some other ones would be bushfires in Australia. That was a really serious issue, and suddenly everybody woke up to the fact that if the outdoor air is bad, most likely the air in your building is terrible. Mm-hmm. And same thing on the West Coast with fires, wildfires, people not knowing, do I go to the office, do I stay at home? It really being in the exact same position that I was in 6 years ago. Yeah. Like, I have no idea what's going on and no idea what I should do. And so those have all been triggers, and definitely COVID has sort of globally accelerated that trend, because each one of these triggers, it sort of acts as a catalyst to speed things up a little bit more. I think the general trend has always been moving in the direction of, we need to understand in real time what's happening within ours. And then I'd add maybe another shift that we're seeing now, which is also more on the sustainability side, and recognizing that, and I know we might talk a little bit more about this later, but recognizing that HVAC systems account for an enormous portion of our planet's greenhouse gases, and the more intelligently we can make those run, the better it is for the planet and sustainability goals. And the two need to be in sync, health and sustainability. And so I think that's also been a bit of a catalyst in maybe the past year or so.
Absolutely. All right, so let's do kind of like a state of the wild, wild west a little bit real quick, like a rapid fire round. So like, where do we sit today? And this is gonna be really difficult to answer. I just kind of want to give like a broad summary, right, of where indoor air quality sits. So Shona, like when we think about new buildings, is it standard to put indoor air quality sensors in new buildings today? And which types of buildings? And then like when you think about existing buildings, is everybody going and putting them in today retroactively? Give us a sense for like what the market looks like.
Yeah, I really think it depends on the sector. The workplace sector is definitely leading the charge when it comes to new construction installations. And so when I'm thinking of deployments, there's the core and shell deployments that are, would be in the duct of the HVAC system versus indoor air quality monitors, which Kaiterra focuses on. It's not, in my eyes, the norm yet to be deploying air quality monitors across the entire workplaces, but we do have certain clients that are doing that. One client we worked on a project with a good while ago was the General Services Administration. And they were really just trying to test out how indoor air quality monitors could support their existing post-occupancy evaluation protocol. They tested that on a pilot project in one of their Chicago locations. And it was so awesome then to see recently that on a new construction project, they deployed monitors across their entire square footage. And so it's starting to become those forward-thinking clients that are deploying them across the portfolio or across new construction projects. And then we are working with a number of tech clients about how to incorporate it into existing buildings. The biggest challenge we're seeing there is around the procurement process. And so getting these monitors actually shipped to different project locations. The other part is installers. And so part of our deployment process is, and Liam knows this, is that we have a training program for hardware installers to understand how to physically install the monitors and then partner with us on commissioning the monitors. And so those are two key kind of blockers, I guess. And the third one is just the installation cost. Sometimes integrators are charging the same amount for the monitor as to actually install it. So those three things are definitely barriers, but we are seeing them start to be deployed on larger portfolios.
Very cool. Liam, that question's probably too hard for you to answer, given all of the vast diversity across the whole world.
Yeah, I mean, I would just maybe add that on definitely on the tech side, I think is that you see a lot of sort of movement there, and that is, I think, in many ways tied to the fact that it has become, I'll say, easier to measure the ROI, but that there's a couple of things. There's in the tech industry, there are some very clear commitments towards sort of carbon neutrality goals. So that's one piece. And the other thing is also on the side of, there's enough research out there that shows the impact of having improved air quality. And, the tech industry pays workers high wages. And so the ROI on that suddenly can start to make a lot of sense when you actually do the math, reductions in absenteeism, for example. So yeah, a lot of movement on that front.
Interesting. Makes perfect sense. So let's talk about certifications then. So you guys have already mentioned Reset and Well, right? I'd love to get a sense for where we're at in the wild, wild west of worldwide. Like, are there leading certifications? Which ones are leading? Are there others besides those two? Kind of like, where are we at in terms of consolidation, like that sort of thing?
Yeah, Liam and I did a presentation recently for internal indoor air quality champions at DLR Group to compare and contrast the different certification requirements for, say, Well, Fitwell, LEED, and Reset. Honestly, as two people who think about air quality probably more than most, it's really difficult to navigate the expectations for each of the standards. My bias is towards the Reset standard because it's just very, very clear on the intent and the deployment process, and it's evolved with time. And so even with the new version, it's focusing on all areas where occupants will be, versus in the first standard, it was more where occupants spend the most time. And so to me, that standard is providing thought leadership and rigor, both for the deployment professionals, but then also the hardware manufacturers. And then, even DLR Group was able to become a Reset accredited data provider. So, the guidelines around how to manage indoor air quality as well, that indoor air quality data. So to me, it's a more holistic standard that really acknowledges the realities of boots on the ground of doing these deployments. And I had heard in the past that Well and LEED were going to fully align with Reset, but I don't know, Liam, if you've seen that come to fruition. The standards seem to be deviating more than they are actually converging.
That's what I was going to say. Everyone's got their own slightly different take. And that's also, in some ways, I think, been accelerated by sort of what I was saying, how you have these kind of catalytic events, and the motivation or sort of the driving factor behind a standard is often tied in some way to its geography. And so if everyone's concerned about wildfires, then there might be more of a focus on particulate matter. A pandemic comes around, everyone's focused on CO2, other, let's say, more indoor contaminants. So yeah, they've definitely gone in slightly different directions, but all, I think, generally following the same path. I think Well is doing a lot on this front as well. Now, obviously, Well is not just an air quality standard. It's much larger, more holistic. So if air quality is the single concern, Well is definitely overkill. But I think there's, and I guess I should preface by saying that I'm also on the advisory committee for the Well air feature and also performance rating. So may have some sort of bias here because I've been looking through a lot of documentation, but I think there's a lot of really interesting things going on there in the right direction. Also looking at, how can we utilize this data to better understand the overall performance of a building, and shifting away from, or not shifting away, but really flushing out the uses for continuous monitoring rather than just sort of point in time samples, which is where historically the industry has been.
With that, when we create these standards for air quality, or air quality deployments, based on a certain event, like those events change all the time. Obviously, we can't gather data for everything, but one thing that has really struck me through the deployments we have done is most of the valuable insights that we've gathered were not the insights that we set out to gather when we started the deployment. So, when we first deployed air quality monitors in our office portfolio, I used to check my air quality app every morning the same way people look at, social media apps, right? And I remember seeing our San Francisco office, the particulate matter in there was so high, I'd never seen anything like it. I emailed the office leader to say, like, something's wrong with your HVAC, like, do not let people come in today. And her response was, have you not looked at the news yet? And there was fires outside, right? And so, we didn't, particulate matter at the time was not something on the tips of the lips of any American, right? It was more something that was focused on in China. And so even with the pandemic, there was more unanticipated insights. When we had our stay-at-home orders, we saw our CO2 levels go from up and down 600 parts per million every day to just flatlining. And then that was at least just a way to show friends or people who didn't understand air quality, like the impact of humans on air quality. But then also when we started the conversation around what are we going to do when we bring people back to the office? Obviously, we had our own air quality platform. We could put that on a kiosk in the lobby. We already had the monitors, but what were we actually going to ask the HVAC operators in the building to do? And so at the time, I think a lot of discussion was happening around doubling the ventilation rate in order to make spaces healthier. But the biggest question was doubling it beyond what? Like, what was it before? And we actually had that information. So we could look at our air quality data and say, okay, we knew that the CO2 never reached over 600 parts per million on a typical day. ASHRAE is saying that, 1,200 ppm of CO2 is the max. So we're already twice as good as ASHRAE is saying. So we could release any expectations for the HVAC operators to actually double the ventilation load, right? So to me, when we think of what we're actually trying to measure, it's hard to say what those future insights will be, but I feel like being able to gather at a wide scale can, I guess, answer more questions.
Absolutely. That's fascinating. So still on our rapid fire question, how about, what's if we could draw generalizations around this, making the business case. So, you mentioned all the research from Harvard, got Healthy Buildings back there on the bookshelf somewhere. It talks a lot about trying to quantify cognitive function, quantify productivity. We're obviously in the world of ESG and sustainability as well. So where do you guys feel like it's at in terms of quantifying and making the business case for investments in indoor air quality?
I feel like Shona might have the best take on this one.
The first time we had to do this was internally when we were asking for funding to deploy air quality monitors in our spaces. And so the conversation we had with the executive leadership team was actually just sharing observations from past school environments where we could see that there was multiple classrooms that were grossly underventilated, and we had started seeing the research emerging around. This wasn't even when the Harvard School of Public Health information that came out. This was beforehand where the World Health Organization had said that if the CO2 level was above 2,000 parts per million, you go into sleep mode. And so there was a day in the Chicago office where it was, -10 outside. The space felt stuffy. And I took a photo. We had a flexible work environment at the time, and you could actually see that most people had gone home for the day. And so part of it was around, we knew that other buildings were being underventilated. We had started to see our own anecdotal behavior around underventilation. And so there was kind of a cost of not doing this initially, and the risk associated with that. And then part of it was around, and I think something that has continued to be a conversation with our clients is around thought leadership. You know, indoor air quality has become personal to all of us now, and being able to tell your employees that you're doing that extra mile to let them know that they're safe, I think is key. You know, it's obviously productivity is a really important metric, but you can't really measure productivity if the people aren't there. And so now this is becoming part of an integral return to office solution. And so when we talk to our clients, it starts with understanding the coverage area necessary in order to get realistic insights into the health of the air. And then the other piece is around communicating this to a non-technical audience, and also managing the risk of sharing live data that's really personal with non-technical occupants.
Everybody has experienced that moment where you're sitting in the conference room and a meeting feels like it's dragging on too long. And, you know, sometimes it isn't even. That's just the feeling that you get that is generated by the poor air quality. You know, you just feel like, I can't think, like we're going in circles. I feel hot and stuffy. Like, you know, it's just really unpleasant. And sometimes that's because, you know, the meeting is poorly run, but sometimes it's just a vicious circle of too many people in a poorly ventilated room. And it's a natural human sort of expression of like biological feature of being in a cramped, closed environment. Like any other, you know, at the end of the day, we're animals, right? Any animal in a closed, confined space with too many other animals is going to go, this is terrible, let me out of here. And that's all we're doing. And, you know, subjectively, we've all felt that. And you open the doors and windows, everyone walks around, comes back and is like, okay. So that's now, you know, can be quantified by data, and it's very easy to you know, to be able to compare those side by side and understand, I think, very quickly, like the changes in efficiency. I think another really interesting thing is what Shona was sort of saying about how you often don't know what you're going to find, but that can often be the most interesting thing. So I mean, we've been looking at data from a project recently where all of the conference rooms on a certain floor are performing significantly better than conference rooms on other floors. And I should say, this is actually what we're looking at is really some insights that are derived from the raw data. It's not the raw data, and maybe we'll talk about this more in a moment. But at the end of the day, it's not really about the raw data. It's about what can you extract from that data, and what are the insights you can pull out of it. And so one of the things that, you know, we've been looking at is essentially the background chemical off-gassing rate. So looking at rooms, what is the rate, let's say, per square foot per minute at which chemicals are being given off? And so that's independent of how the space is used or really anything else, you know, the ventilation system. And so looking at this, you're able to see how rooms that are otherwise similar might be off-gassing at different rates. And what we've seen is that, you know, one floor is much better than any other.
Okay.
And, you know, so there are going to be obvious physical differences between these spaces when it comes to the materials used. You know, do you have the same types of tables? Do you not have tables in this space? Do you have artwork on the walls that were freshly painted? You know, chemicals can be given off by all sorts of things in a space, and they can last for a very, very long time. And when you're seeing one floor that is performing 4x better than anywhere else in your building, that's really interesting to take as an insight for determining how you build your properties going forwards. Your considerations about material selection, yeah, just all of that. So I think that's, you know, there's some really concrete takeaways that can be extracted from the data that often you would never have even considered when you installed the monitors.
Yeah.
And I feel like even the question, what's the business case for it, is kind of framed in the wrong way, given these answers, right? So I'm asking, what's the business case for adding it on? And can you identify one revenue stream that it impacts? And what you guys are saying to me is like, maybe not, but what I'm hearing is like, flip your perspective here. And this is more like infrastructure for a building that you don't know. It kind of supports so many different things and you don't exactly know what it's going to support and how it's going to improve
It's
directly
kind of
the operation.
totally, and it feels kind of like just, often we're just driving blind without this, and it's like Shona said, it's more the cost of not doing this is really high. I think one thing that sometimes confuses people or it makes it hard is that there's so much data around having improved indoor air quality. I think everybody can. It's very easy to say, okay, improved air quality. There's 25 studies that show,
Yeah.
this is better, this is better, this is better. The thing is, how are you going to get improved air quality? It isn't just by pushing more fresh air into the building, or maybe it is, but maybe that isn't going to work, or maybe it's that is an incredibly energy inefficient way, which also means expensive way to hit your goals. And so trying to get improved air quality without having this foundation of knowing what is my air is just an exercise in futility.
Fascinating.
And I think what we keep gravitating towards is like value versus like business case. Part of me is reflecting back on talking to different clients before they pressed go on their air quality initiative. And one thing, just looking back on that, is that decision is made by multiple stakeholder groups. And all of those stakeholder groups have different metrics and different definitions for success. And I feel like the same way as most of the smart building conversation, indoor air quality can impact operations in a different way to HR, the occupant, and all of those impacts are valuable. To me, obviously closing the loop on the design decisions and how the design decisions impact the resultant indoor environmental quality. To me, it really helps me look at air, because if I'm trying to unite an architect, mechanical engineer, and an interior designer on a building system, air quality is such an awesome way to point to how all of their decisions impact the resultant building. And then the other piece is just allowing occupants the ability to decide what's wrong. When I've poured over so many satisfaction surveys in my work, and there's really emotional reactions to being in a space for a long period of time that they can't control. And so if you provide occupants with this data, they can at least try and troubleshoot whether they need to, open a window, modify their clothing. One example comes to mind where there was a school district that all of the surveys were saying that the air quality was really unhealthy and was making people sick. They had headaches and they didn't want to come to school. And when we did our assessment, the air quality was actually fine, at least with the sense variables that we were using. And the issue was overlighting. They had done an LED replacement. They'd done a like-for-like replacement. And so it was a more efficient bulb. So there was more lighting. And as a result, that was actually what was causing the headaches. And so I feel like humans we're great sensors, but we're not very good at dashboarding anything. And so, having this data, I think, can become a change management tool, and it can really impact the culture of the occupants in the space.
Fascinating.
I mean, it's just like going back to that meeting thing, right? I think that's a great quote that you had just there. I mean, it's you're in a meeting and you walk out going, "Ugh, like my boss sucks," like that.
Right.
But it's like, no, you're just like 12 people in a room that was designed for to be ventilated for 3. Like that's the fundamental problem.
Absolutely. Hey guys, just another quick note from our sponsor, Nexus Labs, and then we'll get back to the show. This episode is brought to you by Nexus Foundations, our introductory course on the smart buildings industry. If you're new to the industry, this course is for you. If you're an industry vet but want to understand how technology is changing things, this course is also for you. The alumni are raving about the content, which they say pulls it all together, and they also loved getting to meet the other students on the weekly Zoom calls and in the private chat room. You can find out more about the course at courses.nexuslabs.online. All right, back to the interview. All right, so last piece of the Wild Wild West puzzle here in my mind is I feel like when I've talked recently in the last year or so about indoor air quality, I've been sort of complaining about it being a standalone stack, standalone solution. So let's come in here and in our history of silos in the buildings industry, let's add a whole nother silo, right? And even I posted recently on LinkedIn about the Healthy Buildings book and about how I feel like when I read that, it looks at it as a silo. And as we know, it's not. Healthiness is not one job to be done, or it is one job to be done out of many jobs to be done in the building. I felt bad about calling it out because it's such an impactful book and it's such an amazing book, but like I had to point out that like that's not the only outcome that we're optimizing for. And so I feel like I want to get you guys' take on where we're at. So when I set up the Kaiterra monitor, I had many options for integrating it with other stuff if I wanted to. So I feel like I already know the answer to this, but where are we at in terms of the industry, in terms of standalone stacks or fully integrated stacks and with everything else that we're doing?
I feel like we've had this conversation, Liam, when you let us know that your device was BACnet enabled, right? So that was like a super exciting opportunity for the future. But when we're talking to clients, a lot of the time, most of the time, they want a data visualization tool that is allowing them to do threshold analysis. And the trend analysis piece is something that we would provide as a consulting service a lot of the time. And so all of our deployments to date have been a standalone stack with conversations around BAS integration. It hasn't been something that we have seen implemented yet. The goal is for it to be implemented on a project we're working on right now in Dublin. But you know, the fear around that is having not desired changes made to the HVAC system because of this new sense variable. Obviously, it is the holy grail, right, to take a sense variable and automate the outcome. But right now, that's not what we're seeing.
Yeah, this is a multi-layered kind of topic to unpack here. So maybe taking a couple steps back, like what do people want? People want, first of all, they don't want more data. More data is like the short term, you know, I want more data so that I can do X. And X is have a better building, which ultimately is to have a better space for people, or it's to create a better environment for occupants. What we're really focused on right now with a lot of our development at Kaiterra is really about shifting from raw data to much deeper insights and being able to identify specific changes, specific problems, specific sources. Because something that we've really realized is we have an insane amount of training for our like internal staff. We have something called Kaiterra University, which is basically like a full-on university course, and we've got 12 videos each, over an hour long about air quality that all our staff go through. Oh, wow. Like most of our people working in marketing have degrees in chemical engineering and stuff. Like, wow.
Can we go to Kaiterra?
Yeah, can I go through this course?
Yeah. I would be happy to share some, but it's really in depth, and then we have lectures, and then we have class discussions, and we do batches. So it's pretty involved, and the reason we do this is because air quality is a complex topic that is, I mean, just even CO2 is a complex topic, let alone everything else that matters. And so you can't expect, let's say, the building operator or whoever is consuming this data to look at a bunch of graphs and go, oh, okay, it's because of the table that I installed on the third floor. Maybe I shouldn't use that going forwards. So really, we see it as our job to work all of that out and be able to use data to build models of how a building is functioning. Based upon those models, understand what the issues are, what the changes that need to be made are, and then ultimately make those changes. And that could either be through sort of specific reporting saying this requires human intervention, you should do A, or by telling the building management system you should do B because this can be automated. And we're not fully there yet. This is a big work in progress, but that's definitely where we're going, and I think where things need to be, because as long as you are just throwing data at people, then basically you're asking everybody that's running a building to have a PhD, and the world isn't built that way. So this is, I think, fundamentally really, really key, is that we need to be providing the building with suggestions for what to do so that it can automate those. And that's also, that has been sort of, as you alluded to, driven a lot of our design decisions around building a product. It should plug into a lot of different things. So the SenseEdge Mini that's on your wall there has like RS485 pins, so you can run Modbus. It's got an Ethernet port, supports BACnet over IP, MQTT. You can go via cloud, local. Ultimately, I see these systems being connected to two places at the same time, and that's kind of how the SenseEdge Mini has been designed, which is that data needs to go to the cloud, because if you want to make intelligent decisions, it's not just a simple control algorithm that says, okay, CO2 is over 600, increase ventilation, that's it. It's models have to be run around the building. You need to find out what those areas for optimization are. Those need to go back to the device, and then we get into the control piece. And so it needs to talk to the building management system. It also needs to talk to the cloud so that you can process entire buildings at a time and not just this one device connected to, a VAV box, for example.
Got it. I love that. So is that kind of like the next phase of this then, is like start to think about closed loop and getting into using the data in control?
Yeah, totally. And I think, there's two ways that you can approach it. There's kind of the simple way of just basic control algorithms, but what we've seen is that air quality isn't simple. It's not like temperature and humidity. Temperature, you're too hot, okay, it just means that you need to bring the temperature down. Problem solved.
Yeah.
And you can also see what the energy implications are of making that decision are. It's very straightforward. If we take an example like when the wildfires are burning on the West Coast, what do? Do I bring in more outdoor air? Okay, it's polluted. If I bring in more outdoor air, I need to know how efficient this building is at filtering that air, before I can even consider whether or not this is the optimal choice. Another option is, let's say I bring in less outdoor air and I'm recirculating more indoor air. And it's going through the filter, so it's effectively being filtered multiple times. So my particulate matter levels will be dropping significantly if I do that. Obviously, that has an impact on CO2. How do I balance these two things together? What is the impact on VOCs? Well, that depends on how much this room is off-gassing chemicals.
Mm-hmm.
So I need that background rate. So there's so many inputs that need to go into this model to make the right decision.
So all of that is beyond the capabilities of 99.9% of building control systems today, essentially.
Mm-hmm.
Yeah. So someone has to basically do all that math, make all those decisions, and then maybe control can start being optimized from there.
Exactly. And the thing is, it's very niche and very specific. And that's really what we've realized over the past few years, is that you can't expect really anybody else to do this, because it requires so much specific air quality knowledge. And we're uniquely placed to do that, because we've been making this stuff really since there were continuous monitors on the market. We made really the first products to ever do this, and we've just spent so many years building this knowledge. You don't necessarily feel it, but when we're talking like internally, it's sometimes it's easy to forget that. But then when you're talking to somebody that's running a building, and you go, oh wow, yeah, you actually, this is all sort of in my head. We should really build it into a piece of software that can do it for you, because I can't expect you to sort of absorb 6 years of of knowledge in order to do your job and run your building.
And I think there's some little wins. Like one thing that we always bring up as part of our sustainability goal setting is around air quality monitoring. And if the client doesn't really have an appetite for a full-blown, reset accredited building, we have talked to them about, you have your code required CO2 sensors. How about replacing those code required CO2 sensors with a device that measures multiple variables. So items like that can lead to, in addition to having that data feed to the BAS, have it feed to a kiosk in the lobby as well. So I feel like there's little wins like that. I kind of break it out in my head to what we can do in, say, smaller, densely occupied spaces like conference rooms, focus rooms that have a higher sensitivity versus the open plan space. With the conference rooms in particular, we did a research project with UC Berkeley. Jovan Pantelik was a researcher there at the time, where we were trying to identify what indoor air quality variables could actually predict the utilization of the space. And so, obviously there's so many different utilization solutions coming out right now. And so is there a way to predict occupancy with, say, just a certain CO2 monitor? And what we found was, for a lot of the utilization sensors, there is for an infrared sensor, at least there's a degree of inaccuracy. And we could use relative humidity in CO2 to actually have the same level of accuracy of how many people were in the space. And so to me, that becomes like a dual benefit of the integration, where maybe, you're just using the CO2 feedback. CO2 and relative humidity are terms that our building operators are typically familiar with. So being able to combine them just so that they know which rooms are occupied can, again, layer on more value to the same data.
Fascinating.
Totally.
So, okay, so we've kind of started into this question around what should an IAQ strategy be integrated with in terms of like whatever, everything else that's going on in the building. I'd love to just run through a couple of more of my ideas on other places it should be integrated with and get your guys' take. So another piece is like, I think we've talked about this. We've talked about integration with controls, right? What about, Liam, you mentioned turning insights from the sensors themselves into action. And so I think what I've heard from you is that there needs to be a layer of analytics that helps me get to the action quicker, rather than saying, hey, here's this dashboard with 5 pieces of data on it, streaming all the time, do something with that, and then multiply that by all the rooms you have sensors in. That's insane, right? So the ability to then take the insights into whatever their workflows are on how they're managing the building today. What would you say that like the best practices are there today?
I mean, I think it's definitely a work in progress, and it depends a lot on how the building is organized, how you're measuring your air quality. There's a big difference if you're measuring every single room versus, let's say, 1 monitor per floor, and having spaces tagged correctly is also really important. Going to the point like Shona had with using data from monitors to identify occupancy in a specific conference room, that can be quite easy because the changes can be so fast. But in, let's say, an open plan office space, that can be a lot more complicated. And of course, you've got an air handling unit making everything complicated by pulling the air from the whole building, mixing it together, and then pushing it back into the space.
Yeah.
So it doesn't, if CO2 is increasing in one room, it doesn't necessarily mean that anyone is in the room. It's just that the building has more people in it.
Totally.
And so having spaces be sort of tagged correctly so that you can run the right analytics on it is a really key piece of that.
It's kind of bringing me to think about the steps in our IAQ deployment strategy. I feel like most people think of, an IAQ deployment strategy just starts with marking up your floor plans for where the monitor goes. We front load the process with a lot of design thinking to talk about strategy. And that is because we have met with so many groups that did a large scale deployment of a technology, but the use case wasn't really understood.
Yep.
And so we typically have our designers do a full visioning exercise with all stakeholder groups associated with an entity, right? So say the one that we're working on right now, we had 12 different stakeholder group meetings, and everyone from their security team to their design team to understand user stories. So each 1-hour meeting typically results in like 40 or 50 user stories around, I want to know this about a space so that I can do this thing in my job better. And, we typically end up clustering those 300 to 500 user stories into data use cases. And so typically the data use cases, as we mentioned, are broken down into like, is it room by room? Is it a certain room type that's your area of interest? Is it floor by floor or building level? And that equates to a recommendation for hardware. And so when we get to the point where we've already done visioning, stakeholder engagement, and then also evaluated the data gaps that they have, the hardware recommendation is normally like, we have these spreadsheets internally that compare, say, every air quality monitor on the market or every acoustics monitor on the market. And then we do a 10-year cost of ownership just to try and figure out which monitor actually makes sense for the client based on those data use cases. And then we'll do pilot deployments where we very clear success criteria to then verify if it has been met before doing a full deployment. So I feel like obviously you can go ahead and deploy monitors and see what happens, but I do think that the investment in this technology is significant, and it's also a very visible piece of hardware in the space that people can see. And so I think that front-loading process has really helped make sure that the deployments are successful and they actually meet the questions that you're trying to answer.
Totally. I mean, that's exactly the process we teach in our foundations course, is obviously not in that level of detail and probably not with that level of expertise, but yeah, start with the workflow of the person that needs to use the data and how are they actually going to use it and how's it going to update their workflow after that. All right. So another area that I think is important from an integration standpoint is a lot of building owners, I hope, have started down the path of fall detection and diagnostics, right? So we're talking about turning sensor data into action, right? Well, there's another software suite that already does that, right? So how do you guys think about integrating with other sort of analytics packages that a lot of times are also coming up with analytics on the HVAC systems and their performance as well?
Yeah, we're doing that right now. When we started gathering indoor air quality data, we typically download the data from whatever the proprietary dashboard was, and we'd run our own analysis. But because we have a fault detection and diagnostics team in-house, we started to just integrate to the sensors themselves and pull them into SkySpark. And so honestly, that to me is just a necessary part of the workflow to be able to analyze a large amount of data in a data analytics platform like that. And so we have done it both ways, where sometimes the client wants to integrate the data separately, and it just creates inefficiencies in the process. I also think we have a lot to learn from the monitoring-based commissioning or fault detection diagnostics industry around data analysis, the types of trends that they see on every project, right? And so I think that just comes from that partnership. And sometimes if we have different teams across an entity all gathering the same data, using the same tool to at least bring it all together can be an alignment solution.
Absolutely.
Like, from our perspective, we see ourselves as really being flexible in that, we don't want to force everybody to use yet another dashboard if they've got their dashboards. But what we do want to be able to do, because we think it really delivers value, is interpret some of that data for you so that you don't, again, need to have the PhD. And so an example of how that could tie into this is, for example, understanding the efficiency of the building's filtration system, which we are uniquely placed to do because we've got the raw data for how the sensor is performing, but we also have one of the world's largest databases of outdoor air quality, because we collect data from satellite imagery. We do a lot of processing. We work with multiple sort of bodies like the EPA to collect data. We also have our own outdoor sensors. So we've got this vast database of what's happening outside the building as well as inside the building. And so if we're talking about things like fault detection, that's kind of an example of where you can start to see how equipment might be varying in performance over time. And we are uniquely positioned to be able to give you some of those insights. But again, you don't have to use it through a specific dashboard. If you want to get that via API, that's also fine. Ultimately, it should be convenient for the end customer and make their life simpler. Like that's the goal here.
Really, really cool. Really cool. I think that is a really compelling feature to combine insights from different places and then serve them into whoever needs those insights. Absolutely. All right, a couple more here. Shona, you mentioned occupant facing applications. So like, what's the best practice around, okay, I have this data. Hopefully now I've turned that into some sort of insight. You mentioned, I think, kiosks for occupants, right? But we also have, we're in the days of the tenant app explosion, right, as well. What's the best practice in terms of showing potentially uneducated, I mean, I would consider myself uneducated as well, someone that's not a PhD in air quality, what's the best practice in terms of showing them what the air quality of their space is?
That was a big discussion at the start of the pandemic, actually. There was kind of it divided the air quality industry. I think there was kind of a school of thought that we shouldn't be sharing this data with occupants that don't understand it. And then there was another group of people who were focused on wanting to share what we have. And to me, it's just a data visualization challenge. Like everyone knows the red light, green light system, red is bad, green is good, right? And so to me, you can have a tiered layer approach to the data that you're sharing. So something like a kiosk where the audience is someone who's passing by, they're in transit, they have like a second to ingest the data and either feel good or panic. And so to me, that's where, that kind of just air is good, air is bad with smaller text around the sense variables can really help. But then some people want to know more. And I think that's where the tenant facing applications can really help. We've integrated to multiple tenant applications for that reason, so that you can look at your air quality data and then look at something else you want to look at in your tenant application. I think the other piece though, and something that we're working with multiple clients on and actually developing a tool in-house, is to pull air quality data alongside some of the other metrics around, maybe if you're planning your week at the office, you can also see what the air quality is like while you're planning that. Or maybe you're deciding which meeting room to pick. So you can get a push notification that this meeting room has 4 meetings booked today, and it typically takes X amount of time to return to healthy levels. So maybe pick this other room. So I think when it comes to the occupant facing applications, there is going to be more of that data overlap that Liam mentioned. And the other piece is what happens when your office goes beyond the 4 walls of your building. And so how do you allow the occupants to understand, or the staff member to understand their air quality when they're an occupant in the workplace that you're providing, versus just like you're doing now in your own home, you're the occupant of your own home. How can you actually quantify the air there?
Fascinating.
On the topic of there's a school of thought of we shouldn't share data because people don't understand it. And I have a lot of experience of that backfiring for clients.
Mm-hmm.
It's not 15 years ago where nobody could measure air quality. You can go on Amazon, you can buy a product, and then you can walk into the building and go, hey, and then you can post it on Twitter. And this is something that you want to be proactive about. If you're measuring the air, it's an opportunity to do good. And I have a lot of horror stories. I once met someone from an international, like a private international school in, I think it was New Delhi, and we met and exchanged business cards. He looked at my business card and went, I hate you guys. And it was like, I have so many parents buy your products and then like send them in the backpacks of children into school and take readings and then come to me and be like, hey, you guys aren't doing what you need to do. And
wow.
So yeah, like this is happening all over the place, and it's an opportunity to be proactive rather than deal with that.
Probably the TVOC is the backpack just offcasting onto your mind.
Right. I mean, there's so many ways that this whole experiment was flawed.
But But you bring up a good point, and I guess that's back to the business case. That's where it started for us in schools. There's a lot of monitors on Amazon that look like little Fisher Price toys, and they're air quality monitors. And people were seeing students have those clicked onto their backpacks. And if that's the only data set that's available, even if it's a really inaccurate TVOC monitor, it was the only data set, so it was the best data set, right? So I feel like that's where selecting an accurate monitor and actually having that shared with occupants, it eliminates that risk.
And maybe
it seems like transparency is the default, should be the default position at this point.
Mm-hmm.
Yeah, I just add on to your comment there about the Fisher Price monitor and the Wild West of monitoring. It's really, really hard to know, and this is why standards like Reset are, I think, so helpful, is because they've set, standards for what is acceptable, what's not, and they actually physically test products to make sure that they're okay. Whereas what you buy on Amazon could be absolutely anything. And there's a case of a consumer grade monitor that I won't name, extremely popular, and it claimed to be measuring CO2, but if you physically take the device apart, there is no CO2 sensor inside. And this is surprisingly common in a lot of applications still.
How is it making that data?
So it's using a sensor that's designed to measure VOCs, and there's typically a high correlation between CO2 and VOCs because a lot of VOCs are human generated. But there is absolutely no way that you can conclusively say that there's any degree of CO2 based on VOCs. I mean, you open, a whiteboard marker next to it, and it tells you that, there's 10,000 ppm of CO2 in the room. It's just, and of course there's issues with drift. So this is an example of a device that, you look at the tech specs and it says that it measures CO2. You physically take it apart and the sensor is not there.
Wow.
And, yeah.
Wild West indeed. Wow. Okay. How about, so speaking of sort of so there's a procurement aspect, but where my mind just went was the maintenance aspect. So the ongoing piece of this, if I'm a building operator, I got 12, 15 things on my to-do list. And now I'm saying, hey, now there's all these sensors that we're adding in that need to be calibrated and maintained and potentially replaced, the internal components, right? So how do we integrate IAQ into the O&M process? Like, what's the best practice for that these days?
I mean, from our side, we've tried to make that as simple and straightforward as possible by, avoiding sort of the problem that Shona was describing earlier of like, yeah, sure, just, ship them to China, but recognizing that, absolutely there's still a cost, be it mental, human, whatever, in making sure that devices are accurate, and that you need to, maybe once a year, once every 2 years, swap out some of these modules or cartridges that are inside sensors. And really, it's just about being proactive about that from day one, and having that put on a schedule with a responsible individual, in the same way that you would maintain your air handling unit and change filters. Yep. This is something else. At least you're not needing to do this every 3 months or anything. The time frame is significantly longer. We tried to make it as easy as possible.
How about you, Shona, from a design standpoint?
Yeah, this has definitely been a very long conversation with a good few clients because there isn't standard best practices for it, honestly. And typically we have a series of meetings with all stakeholder groups and create a playbook for like what they need to follow once we walk away. But the problem is kind of like energy, where an energy bill goes to the accounting office and someone pays that, and then someone else is the person impacting the energy bill and they never talk.
Yeah.
To me, it's kind of the same with air quality monitoring, where it may be, the head of workplace deploying air quality monitors across their entire portfolio, and they're seeing a threshold analysis around if the air is good or bad, and that's what they're looking for. And then the air quality monitors are not actually connected back to the building automation system, nor is there a data visualization tool around administration of the monitors. And this is something that we're trying to work on, is like a visualization that says like, here's the amount of time left on the filter. And some of this Kaiterra has. Here's the mean average error of each of the monitors. So maybe one of the monitors is drifting faster than another. And then also just having this be part of the proactive maintenance plan for the facilities engineers. Another thing around this is, it is similar to filters where you have to have a stock of replacements and then decide when to do the replacement. And so when it comes to contracting, at least, typically everyone's purchasing the monitors and focusing on the deployment, but the actual bulk ordering of the cartridges is something that still needs to be figured out. And then also to figure out how long can the cartridges stay in storage? How should they be stored before they are not useful anymore? And obviously something Liam can speak to in a little bit more detail. So I think it's something that it's almost being figured out as part of the procurement process and is frequently forgotten. And then no one is actually told when the monitor needs to be recalibrated.
Absolutely. Yeah, it really goes throughout the whole organization that this has to be thought about.
Yeah, it becomes a knowledge management challenge.
Absolutely. So, all right, so let's go with our capstone question here. So I've spent pretty much my whole career before Nexus trying to make sure a building had adequate ventilation, but also try to reduce the ventilation to that minimum because I was trying to help my clients reduce their energy consumption, right? And now the world of energy has expanded into ESG. And I think it's not obvious to everyone that the two goals are sort of in conflict, energy and IAQ. But they're what I like to say is that they're in direct conflict unless you're managing them and optimizing for both. So like, what's the best practice today for trying to optimize two outcomes that are in direct conflict with each other?
I mean, I think energy and air quality has a symbiotic relationship. I think it's just something that needs to be balanced on both. My background is in simulation, and initially when you do a simulation, you always expect that the air quality is actually, that need is being met, and you're just looking at the levers to reduce the energy consumption. So to me, they just need to be viewed in the same field of view. There's going to be situations, as we mentioned, where you need to increase the ventilation in order to purge out something as a toxin that's in the space. There's going to be situations where you need to increase the resistance of the air handler by putting in more filters to filter out the outdoor air. And there's going to be opportunities where you can reduce the ventilation or change your ventilation strategy in order to save energy. So to me, the issue is when those problems are being solved in isolation and not together.
This is what I'm super excited about this because it's where I see the biggest opportunities for improvement, to people on the planet. Air is massively important to our comfort, and it's also where we spend such a vast amount of energy, trying often very ineffectively to optimize it. And they are definitely in conflict. And so it's kind of about how do you tweak those levers to find this balance point in the middle that's optimized. And that's a really interesting optimization problem, and it's where a lot of our efforts are going. So continuous monitoring is really the first step in this, because if you want to do things more intelligently, you need to understand where is waste taking place and then reduce waste. Mm-hmm. So if a space is being ventilated and there's nobody there, that's waste. If it's not going to be used, that's also waste. But there's also, examples of changes that can be made that lead to the opportunity to use less energy. So a simple example that we've seen throughout the pandemic is around cleaning schedules. So what we are often seeing is cleaning taking place in the morning before the day starts in many parts of the world. And what that does is it creates a very often high amount of VOCs in the air. So if you clean the office at 6 a.m., you come in at 8 a.m., and you're basically in a toxic environment, and it takes a long time for those chemicals to drop down. Just like when you burn your toast in the morning, like there's still particles in the air for at least half the day. And what that means is that if you're trying to optimize for air quality, your ventilation system is running on max for half the day trying to flush all those chemicals out of the building. If, however, you shift that cleaning schedule to 7 p.m., right after everyone's left the building, you don't need to run the ventilation overnight. You can just let them sort of disperse throughout the night, and then 45 minutes before the building becomes occupied, turn on the HVAC system, flush the building out, and it's far more effective because you're not fighting the people inside. So that's the one sort of simple example of the insight that can be gained from this data that can then shift how you run the space. Another example that we've seen is just around really over ventilating, especially when spaces are not occupied, especially driven by COVID. This thought of, well, we need to just bring in fresh air all the time. But really, if your CO2 levels are 500 ppm and there's almost nobody in the building, like, you're good. You don't need to be putting more fresh air in there. So having these two perspectives and shifting between them is really the only way to, I think, make buildings that are healthy for the occupants, but also energy efficient.
Awesome. I totally agree. All right, rapid fire round to close out. What are you two looking forward to in the area of indoor air quality this coming year?
That's a tough one. One thing I'm really looking forward to is we're building a showroom for IoT devices in our San Francisco office. And so Kaiterra will be one of the monitors in there, in addition to acoustic monitors, density monitors as well. The goal there is to demonstrate in a real space what this looks like to our designers that are afraid of sensor acne across their beautiful designs. And then also just to experiment with combining these data sets together for deeper insights. So, and then we're pulling that all together into a holistic data visualization tool. So more to come on that, but we've been working on it for a year and getting close to an MVP. So big year ahead.
Very cool. I'm doing something similar. So my Kaiterra monitor is the first. Nexus Labs was named because I'm envisioning there being an actual lab or many labs. So my Kaiterra monitor here was the first one. And yeah, so I'll be doing something similar as well.
Awesome.
What about you, Liam?
Yeah, that's really exciting. So I'm just super, super excited about a lot of what I was talking about when it comes to insights. And we've spent the past year or so really digging deep into a lot of data in a lot of different projects and buildings worldwide and identifying trends that I think were previously not really visible. And so there's been a lot of manual labor that's gone into that. And we've been building a lot of algorithms around extracting that insight. And so I'm really excited. Over the next year, we're going to be turning that into products that people can actually use and get some of this insight themselves, from installing monitors and then just sort of being wowed by, like, oh, this is what's happening. I think that's really exciting. Our team is growing very fast. I think we're doubling, tripling over the next year or so to make this happen. So it's an exciting time.
Absolutely. I'm excited about that. I'll look forward to some sort of update being pushed to me when that happens.
Yeah.
Awesome. Well, thank you two so much for coming on the show. This has been a deep dive, very educational deep dive from two different perspectives that are complementary, but from different angles. So this has been fun. Thank you so much.
Likewise. Thanks a lot.
James.
All right, friends, thanks for listening to this episode of the Nexus Podcast. For more episodes like this and to get the weekly Nexus newsletter, which, by the way, readers have said is the best way to stay up to date on the future of the smart buildings industry, please subscribe at nexuslabs.online. You can find the show notes for this conversation there as well. Have a great day.